Section 7.1 Solving Trigonometric Equations with Identities. In this section, you will verify the fundamental identities, simplify trigonometric expressions using algebra and the identities. Let's start with verifying the fundamental trigonometric identities. We need trig identities to simplify trig expressions and eventually solve trig equations. Let's first define what a trig identity means and then learn about the fundamental identities. Definition: a trig identity is an equation that holds true for all the values of the variable in the equation. Again, true for all the values of the variable. Let's have an example. Number 1 are the following equations or identities. The first one, letter A, 2x plus x is equal to 2x plus 2, and this is going to be an equation. 2x plus x is equal to 3x, 2x plus 2. And when you solve for x, when you subtract 2x both sides, x is equal to 2, so that is an equation. Letter B, 2x plus x is equal to 3x. For all values of x, we can simplify this. 2x plus x is 3x is equal to 3x. That is true for all the values of the variable. So that's why this is an identity. Then letter C, x plus 1 is equal to 2x plus 2. You can solve this. It's like you can factor out 2 if you want, and again this is going to be an equation. Letter D, 2 times x plus 1 is equal to 2x plus 2. If we distribute 2, that's going to be 2x plus 2 is equal to 2x plus 2. And that is true for all the values of the variable x. So that's why this is an identity. E, sine of 2x is equal to 2 sine x cosine x. This is one of the identities that you will learn in this section. This is actually what you call the double angle identity. And letter F, sine squared 3x plus cosine squared 3x is equal to 1. This is also an identity. Remember, like sine squared plus cosine squared is equal to 1. So this is, yes, it is a Pythagorean identity. Okay. Next, here's a list of the fundamental trigonometric identities. Many will look familiar to us, like the reciprocal identities. I'm pretty sure that you remember most of this. So cosecant is 1 over sine, secant is 1 over cosine, cotangent x is 1 over tangent x, tangent is sine over cosine, and cotangent is cosine over sine. Same thing with Pythagorean identity. Sine squared x plus cosine squared x is equal to 1. Tangent squared x plus 1 is equal to secant squared x, and 1 plus cotangent squared x is equal to cosecant squared x. Then also the even and odd functions. Sine of negative x is equal to negative sine x, cosine of negative x is equal to cosine x, tangent of negative x is equal to negative of tangent x. So you all learned this last time. And also we have our cofunction, whereas sine pi over 2 minus u is cosine of u, and cofunction of cosine is sine u, tangent, cotangent of pi over 2 minus u is tangent u. Same thing with the secant and the cosecant. Okay, make sure that you are familiar with all this identities and cofunction. Example number 2, verify 1 plus cotangent squared theta is equal to cosecant squared theta. So every time we work on this type of problem, it's easier if we work on one side only. And then also express the terms with sine and cosine. So the given 1 plus cotangent squared theta is equal to cosecant squared theta. Let's work on the left hand side. So 1 plus cotangent squared, we know that cotangent squared is cosine over sine. Then we can rewrite 1 as sine squared theta over sine squared theta. So plus cosine squared theta over sine squared theta. Then we can combine this. This is now sine squared theta plus cosine squared theta over sine squared. And sine squared plus cosine squared, by using the Pythagorean identity, is 1 over sine squared theta. And using the reciprocal identity, 1 over sine is equal to cosecant squared theta. So now this is equal to the right hand side. Okay. Now let's solve more examples here. Letter A, example number 3, verify that tangent theta times cosine theta is equal to sine theta. Again, we can express terms in with sine and cosine. We know that tangent is sine over cosine. So sine theta over cosine theta times cosine theta. So remember, you can work on the left hand side. Then cosine theta over cosine theta is 1. So definitely this is sine theta is equal to sine theta, which is the right hand side. Okay, then letter B, verify that 1 plus sine x times 1 plus sine of negative x is equal to cosine squared x. So we know that sine of negative x is equal to negative of sine x. So we can rewrite this as 1 plus sine of x times 1 minus sine of x is equal. So let's work on the left hand side. So that will show that it is equal to cosine squared x. So when we multiply this, 1 times 1 is 1, 1 times negative sine x is negative sine x times 1 is sine x times sine x is sine squared x. So negative sine x plus sine x is 0. So this is simply 1 minus sine squared x. And by using the Pythagorean theorem number sine squared x plus cosine squared x is equal to 1. So from here, from this theorem, if we subtract sine x both sides, is going to be equal to negative sine squared x. So this is actually equal to cosine squared x, which is the right hand side. Okay, so we did verify that 1 plus sine x times 1 plus sine of negative x is equal to cosine of squared x. Okay. Next, example number 4. Verify the identity secant squared theta minus 1 over secant squared theta is equal to sine squared theta. Let's work on the left hand side. We can separate this actually. Secant squared theta over secant squared theta minus 1 over secant squared theta, and secant squared over secant squared is equal to 1 minus 1 over secant. Reciprocal identity is cosine, and 1 minus cosine is, again, by using these Pythagorean identity, that is equal to sine squared theta, and that is the same thing as the right hand side. Okay. Alright. Example number 5. Verify this identity 1 minus cosine squared x times 1 plus cotangent squared x is equal to 1. So just to recall Pythagorean identities, that again sine squared x plus cosine squared x is equal to 1. So meaning if we subtract cosine squared x here, so sine squared x is equal to 1 minus cosine squared x. Okay, that's why we have here 1 minus cosine squared x is equal to sine squared x. We're working on the left hand side. Also, another Pythagorean identity is 1 plus cotangent squared x is equal to cosecant squared x. And look at that. That's the given. 1 plus cotangent is cosecant. So we can write here cosecant squared x. Next identity, we know that reciprocal identity cosecant is equal to 1 over sine. So cosecant squared x is equal to 1 over sine squared x. So this is sine squared x. So sine over sine is equal to 1. And that is the right hand side. Okay. Next, simplify trigonometric expressions using algebra and the identities. A lot of times in order to solve trigonometric equations, we will have to use algebra to factor, as well as use identities that we have learned. So let's say example number 8, solve the equation on the interval from 0 to 2 pi by factoring. Given 2 cosine squared theta plus cosine theta minus 1 is equal to 0. So we can rewrite this so that it's easier, it looks simpler and easier to solve. So let's say let u is equal to cosine theta you can do this. So when we do that, now that becomes 2u squared plus u minus 1 is equal to 0, right? And then now this is factorable. So 2u squared, the factors are 2u and u. 1 is negative 1 and positive 1. Because 2 times 1 is 2, minus 1 is positive 1. So this is correct. Then set each factor to 0. So 2u minus 1 is equal to 0. U plus 1 is equal to 0. And solve for u. So u here is 1/2. And u is equal to negative 1. So after we solve for u, don't forget to substitute the value of u, which is cosine theta. So let's say the first one, when u is equal to 1/2, we could say that 1/2 is equal to cosine theta. And remember, like what we did for the last chapter, you can solve for theta, that is inverse cosine of 1/2. And what are those? So theta is going to be pi over 3 and 5 pi over 3. Or if you want, we can recall the unit circle. This is pi over 3, where the coordinates are 1/2 and square root of 3 over 2. And this is cosine. The first coordinate is cosine. So that's why pi over 3 is one of the answers. And the other one is 5 pi over 3. And this is 5 pi over 3 here, where you have here 1/2 and negative square root of 3 over 2. So this is 5 pi over 3. So that's why these are the two answers. That is when u is equal to 1/2. Next is when u is equal to negative 1. So cosine theta is equal to negative 1. Now what are the values? Find theta when inverse cosine of negative 1. And that is, yes, is equal to pi. So again, if you look at the unit circle here, this is pi with the coordinates negative 1, 0. So that's why these are our answers. Okay, let's try another example. Example number 9. Solve the equation on the interval from 0 to 2 pi by factoring. Given here, 4 cosine squared theta minus 1 is equal to 0. So let's try again. Let u is equal to cosine theta. So now, using this, we have 4u squared minus 1 is equal to 0. And factors of 4u squared minus 1, that's 2u plus 1 and 2u minus 1. Difference of two perfect squares is equal to 0. Then we can solve for u. Set each factor to 0. So that u is equal to negative 1/2 and u is equal to positive 1/2. So let's do that. The first one, when u is equal to negative 1/2, So cosine theta is equal to -1/2. Theta is equal to inverse cosine of -1/2. You can use your calculator, or if you remember, using the unit circle when it's -1/2. The answers are 2 pi over 3 and yes, 4 pi over 3. The other one, when u is equal to 1/2, so cosine theta is equal to 1/2, and theta is inverse cosine of 1/2, so that positive 1/2, the values are pi over 3 and 5 pi over 3, just like the last example. So these are the answers. Okay. Next, let's work on some review lecture questions here. Number 1. For the following exercises, verify the identity. So please take a look at the list of identities that you learned in this section and verify these identities. So letter A, cosine x minus cosine cubed x is equal to cosine x times sine squared x. So let's work on the left hand side and show that it is equal to the right hand side. Cosine x minus cosine cubed x, I can factor out cosine of x. And we know that 1 minus cosine squared x is from Pythagorean identity. This is the same as sine squared x. And look at that. That is already the same as the right hand side. That's it. Letter B. Sine x plus cosine x squared is equal to 1 plus 2 sine x cosine x. So let's show the left hand side that is equal to the right hand side. So sine x plus cosine x squared, meaning that is sine x plus cosine x times sine x plus cosine x. Let's distribute this. Sine x times sine x is sine squared x. Sine x times cosine x is sine x cosine x. Then these two, sine x cosine x, and the last two terms, cosine x times cosine x is cosine squared x. Then we can combine this. Sine squared x plus cosine squared x. Sine x cosine x plus sine x cosine x is 2 sine x cosine x. And remember, sine squared x plus cosine squared x is a Pythagorean identity, which is equal to 1. So 1 plus 2 sine x cosine x. And now look at this. This is already the right hand side. Okay, and number 2, solve the equation from the interval 0 to 2 pi by factoring 2 sine squared theta plus sine theta is equal to 0. So you can here let u is equal to sine theta, and then we can rewrite that as 2u squared plus u is equal to 0. And then we can factor out u. This is 2u plus 1 is equal to 0, and set each factor to 0, so u is equal to 0, and 2u plus 1 is equal to 0, so u is equal to negative 1/2. So let's use that. The first one, when u is equal to 0, so sine theta is equal to 0. So theta is inverse sine of 0, and inverse sine of 0, and remember from the interval of 0 to 2 pi, so but show you a unit circle again. Sine that is 0 is this point, whereas you have the coordinates 1 and 0 here, that is 0 and 2 pi. So that's why the answer 0 and 2 pi. They're both, sorry, this is cosine and this is sine. So sine 0 and sine of 2 pi is equal to 0. The other one is when u is equal to negative 1/2. So sine theta is equal to negative 1/2. Theta is inverse sine of negative 1/2. And that is going to be equal to, yes, 7 pi over 6 and 11 pi over 6. So just to show you again with the unit circle, where 7 pi over 6 whereas the coordinates here, negative square root of 3 over 2 and negative 1/2. So this is 7 pi over 6. And the other one here, this is 11 pi over 6. The coordinates here, square root of 3 over 2 and negative 1/2. So look at the sign coordinates here, negative 1/2. So that's why the two answers, 7 pi over 6 and 11 pi over 6. So all in all, the answers are 0, 2 pi, 7 pi over 6, and 11 pi over 6. Okay, and that's it for 7.1. Let me know if you have any questions. Thank you.